Welcome to Physics World Online College, where we simplify physics and make it very clear, simple, and plain to everyone to understand. In our class of today, we will be looking at a continuation of field, gravitational force. So, in particular, we will look at the relationship between gravitational constant, capital letter G, and acceleration due to gravity, small letter g. Before we continue, please remember to subscribe if you have not done so, share, comment, and most importantly, click on the notification bell so that you can get informed anytime a new class is up and available. So we continue with our class of today. There are some salient points we need to know in this class for us to be able to achieve that relationship between capital G and small g. So let's take these points. Number one, anywhere you see the mass referred, called, or named, it also means a body. It also means any object. So mass, body, object, they mean one and the same thing. So if I say the mass of a body, I also am referring to the body or the object. Good. Number 2 point to note is that gravitational force of attraction of the Earth on any mass, the gravitational force of attraction of the Earth on any body, the gravitational force of attraction of the Earth on any object is the same as the force of gravity on the mass due to the Earth, is the same as the force of gravity on the body due to the Earth, is the same as the force of gravity on the object due to the Earth. And that is the same as the weight of the mass. It is the same as the weight of the body. It is the same as the weight of the object. Number 3 point to note is that the mass of the Earth, given by letter M subscript E, is concentrated at the center of the Earth. So it is believed that the mass of the Earth is concentrated at the center of the Earth. Number 4, the distance of any object, the distance of any mass, the distance of any body on the Earth's surface to that center of the Earth is the same as the radius of the Earth, or the Earth's radius. With this point noted, we can obtain the relationship between universal gravitational constant, capital G, and acceleration due to gravity, small letter g. You are expected to know how to obtain it, which is the one objective of this class of today. So let's begin. If the gravitational force of attraction on any body, on a body or mass, on a body or mass M is given as F, the gravitational force, G, the mass of gravity, M E, the mass of G, the gravitational constant, ME, the mass of the earth, then M, the mass of the body, and the distance between them, which I said is the radius of the earth. This is similar to the equation 1 we have established before. So let's call it equation A here. Also, the force of gravity, the force of gravity on the mass, due to the earth, which I have said is the weight of the body. So we say that is the weight of the mass is given by F equals the weight, and by Newton's law, that weight of the body is the mass times acceleration due to gravity. Let's call this equation B. So since equation A represents the force of gravity, equation B also represents the force of what? Gravity. The force of attraction, equation A, the force of gravity, equation B, both of them are the same. We can say, therefore, equation A is equal to equation B. So that will give us that mg is equal to g re squared. Obviously, you will see the mass of the body is common, so we can eliminate it. That will give us G is equals to capital G, mass of the earth, divided by the radius of the earth squared. This is the relationship we need. Let's call it equation 2. So this gives the relationship between acceleration due to gravity and the gravitational constant. I will come back to equation 2 to make some statements. Let's look at equation B again. From equation B, let's make G the subject of the formula. We have that G is equals to force divided by mass. Let's call this equation what? 3. So equation 2 and equation 3 is the bone of our discussion today. So we have obtained the relationship between G and big G. Now let's come to this equation 3 and make some deductions. From equation 3, we can define G, small g, as the force per unit mass on the Earth's surface. Also, we can obtain a unit for G here, which is the force. The unit of force is Newton, and the unit of what? Mass is kilogram. So a unit of G here will give us Newton, divide means per kilogram, or you can write it this way, Newton per kilogram. So which means G has 2 units. The one you know previously, which is meter per second square, and now this new unit, Newton per kilogram. So I said acceleration due to gravity can be defined as the force per unit mass on the Earth's surface. From here, acceleration due to gravity can also be called gravitational field strength or gravitational field intensity. It is also called gravitational field strength or gravitational field intensity. So small g has three names. By virtue of this class, you are taking note of them. What are they? Number one, you call it acceleration due to gravity. Number two, gravitational field strength. Number three, gravitational field intensity. So if in a question they say find the gravitational field strength, you know they are asking you to find what? Small g. So these are two new names you need to learn in addition to the one you are familiar with. And also I've established that g now has what? 2 units. Apart from meter per second square, which you have known before, it also has the unit Newton per what? Kilogram. Good and fine. Then, if we look at equation 2, there are deductions we need to make from this equation 2. What is that? You will see that the value of g here depends on two things. The value of acceleration due to gravity depends on 1, the mass of the Earth, 2, the radius of the Earth. So these are the two things that determines the acceleration due to gravity of any place. Also, to take note, you will see that g varies inversely with the radius of the Earth. So it is one reason why we say acceleration due to gravity varies from place to place. As you will see, if the radius of the Earth is large, it means the value of g will be what? Small. Also, if the value of the radius of the Earth is what? Small, then the value of g will be what? Large. That is why we have to know these points, reasons why g varies from place to place. I would like to use a small diagram to explain that further, which you need to take note of. So let's say this is the Earth. I've told you that the mass of the Earth is concentrated at the what? At the center. And any body we just considered just now could be anywhere on the Earth's surface with mass m. We have said the distance from that mass to the Earth, that is the radius of the Earth. So we have already considered the force of attraction between the mass of the Earth and the mass of that body or that object, which we have established. And we have used it to determine the acceleration due to gravity relationship with universal gravitation constant, equation 2. So we are giving reasons now why g varies from place to place. 1, the imperfect shape of the Earth, or you say the uneven shape of the Earth, or you say that the Earth is not a perfect sphere. That's number 1 reason. Number 2, the polar diameter is less than the equatorial diameter. Look at it. This is the equatorial diameter. This is the equatorial region, the equator. Now, I want you to know other names that this equator is referred to here. You call it the equator. You can also call it the what? The top of the mountain. Top of a mountain. Okay, and you can also call it the equator, the top of the mountain, and you can also call it the what? The greatest height. Greatest height. So when you read and they talk about at the greatest height, or at the top of the mountain, or at the equator, you know where we are referring to. So this is the equatorial diameter. From here to here is the diameter. So half of it is radius. Now, this is the polar diameter. Here, half of it is radius. The full length is what? Diameter. This is the polar diameter. This polar diameter, so this is the pole. You can also call it the sea level or lowland. So when you read and they are talking about at the sea level, you know they are talking about the polar region. They say at the lowland, you know they are talking about what? The polar region. So this is a polar diameter. We can take here too. It's another polar diameter. So let's make our point once again. So we say if here at the polar diameter, you see that the value of arrow subscript E is small. So if arrow E is small, the G here will be what? Large. So you see that G is great at the sea level. It's greatest at the sea level. It's greatest at the pole. It's greatest at the lowland. Why? I said the radius of the earth there is what? Is small. So G will be what? Large. Then you see here the polar diameter. You see here the radius of the earth. Let me take that again. Here, the radius of the earth is small, so the value of G is large or greatest at the pole. Here, the value of what? Arrow, the radius of the earth is large, so the value of G here will be less. At the mountain top will be small at the mountain top. That's correct. So we say the polar diameter is less than the equatorial diameter. One word for these lines, this diameter we're calling in geography, they call it latitude. So which means latitude affects the value of what? Of G. The latitude of the place will affect the value of G in that place. Thirdly, we have that the distance of the North Pole to the equator is greater than the distance of the center to the South Pole. How do we represent that here? The distance from the North Pole to the equator is not the same as the distance from the center to the South Pole. Here to here is greater than here to here. And once again, in geography, any line that runs from this North Pole to the South Pole, we call it what? Longitude. So we can say longitude of a place affects the value of what? Of G. And lastly, altitude, height, and depth of a place, of places differ. Now, the height or altitude, we'll look at it this way. Then the depth, we'll look at it down this way. So the height of a place affects the value of G. The depth of the place also affect the value of G. In fact, this will be one of the concepts of the next topic we will discuss. We will look at the relationship or the variation of G with what? With height. We'll discuss it and solve some problems there as well. So you see that the value of G is less at the top of the mountain, or at the greatest height, or at the equator, since the value of the radius of the earth at that place is what? Large. And also it is greatest at the sea level or lowland or poles, since the value of the radius of the earth is small. So by virtue of this class, you are able to obtain the relationship between small g and big G, given as this. You're able to know that gravitational field intensity, gravitational field strength is the same thing as acceleration due to gravity, and is given as the mass force per unit mass. And gravitational field intensity or strength has two units, meter per second square and what? Newton per kilogram. Most importantly, the reasons why G varies from place to place. These reasons you must know. In our next class, we'll look at this relationship, how to obtain the mass of the Earth. Please remember to subscribe, to share, to comment, and click on the notification bell. Thanks.